What role does redundancy play in preventing product failures? Imagine a car that keeps running smoothly even if one of its critical parts breaks down. That's the power of redundancy in action. It's like having a backup plan built right into the product. When a key component fails, the backup takes over instantly, keeping everything working without a hitch. This approach is vital for making products more reliable and safe. In engineering, redundancy means making duplicate parts or systems that can step in if the main one fails. There are two main types. Passive redundancy involves designing parts with extra strength or capacity. For example, a bridge might have cables that are stronger than needed, so if one cable snaps, the bridge stays safe. Active redundancy is more dynamic. It involves monitoring parts constantly and switching to backup systems automatically. Think of electrical power grids that have multiple power lines. If one line fails, the system switches seamlessly to another line so you don't lose power. Redundancy helps products keep working even when something goes wrong. It improves fault tolerance, which means the system can handle failures without stopping. For instance, in computers or servers, backup power supplies are always on standby. If the main power supply fails, the backup kicks in immediately, preventing shutdowns. This is especially important in critical systems like hospitals or airplanes, where failure can be dangerous. Redundancy also helps avoid failures altogether. By using more reliable parts and safer designs, products are less likely to break down. It creates a safety margin that accounts for wear and tear over time. For example, in electrical systems, multiple power lines and automatic switches prevent blackouts. In vehicles, backup brakes or steering systems can prevent accidents if the primary system fails. In real-world cases, redundancy is everywhere. Electric grids use multiple lines and automatic switches to prevent outages. Data centers have failover servers that take over if one server crashes. Mechanical systems often have duplicate parts like gears or bearings that can step in if one wears out or breaks. Of course, adding redundancy isn't free. It costs more money and makes products more complex. It also means more maintenance. Engineers have to find the right balance, adding enough backup systems to improve reliability without making the product too expensive or complicated. In the end, redundancy plays a big role in making products more dependable. It keeps things running smoothly even when parts fail. It provides backup capacity, allows automatic switching, and supports continuous operation. All these factors help reduce mechanical failures and make products safer and more trustworthy in everyday life.